Hello, good morning. We are going to be lecturing today using screencast. Hopefully this will work out for everyone and we will use this format in the future. This is going to be a lecture on fossil fuels, and it is out of chapter 15 in the book. There's some things I'm going to go over that aren't in the book, and of course I'm not talking about nuclear power today, and that's also a big topic. We're just going to focus on fossil fuels. So fossil fuels are the main energy source that we use in the world to provide commercial energy. It's 85% of the world's energy is used because we burn fossil fuels, which is coal, oil, and natural gas. Fossil fuels are non-renewable, which you know. They were formed when prehistoric plants and animals died millions of years ago and then were buried by layers of rock and sediment. And then different types of fuels will form depending on the type of organic matter. Was it both plants and animals? Was it just plants? That's going to be important. And then, of course, how long it was buried and at what temperature and pressure conditions, because that will form different types of coals that you're going to need to know about as well. Fossil fuel industries drill or mine for these energy resources and then burn them to produce electricity. We use electricity, we refine them for fuel for heating and transportation. And over the past 20 years, nearly 3/4 of human-caused emissions have come from the burning of fossil fuels. Let me just go through really quickly how we generate electricity. It really has not changed since we started using electricity. And with the exception of a few alternative forms of energy, this is how we generate electricity. So basically, you're going to have some sort of fuel source and burn that fuel to create heat. And that heat is going to heat up the water and turn it into steam, because when you boil water, it turns to steam. So that steam then goes through a pipe and it is moving very fast to turn a turbine. So you're going to force that steam into the blades that's going to spin that turbine, and that turbine is going to spin extremely quickly, and then it's going to spin a generator, and a generator is basically wrapped in copper wire, and it is going to release your free electrons. And when your electrons are released, they go through the grid, and then when you switch on a light bulb or something, those free electrons are going to produce your electricity. So no matter what kind of fuel source that you're using, you're basically doing it, basically burning something to boil water to create that steam, turn a turbine that spins a generator, which releases your free electrons, and that's your electricity. And no matter what you burn, if it's coal, oil, natural gas, if it's biomass, if you use nuclear power to boil the water, it's all the same thing once you get that water boiling to produce the electricity. Okay, so let's talk about the formation of coal. Coal is specifically made from the remains of plants which died and that were buried millions of years ago. And over time, that coal is going to change because the pressure and the time is transitioning that coal from one type to another. But you have to know that coal just comes from plants. So if you start out 340 million years ago, you have some sort of, swampy wetland type area with lots of vegetation, and you form peat. Peat is just a organic matter soil made from decomposed plants. Now, peat is not a coal, but peat is the first step in forming coal. So what happens is that your peat becomes buried. It's just your buried vegetation. And then 100 million years passes and it becomes buried, it becomes pressurized, and you form your first type of coal, which is the youngest type of coal, called lignite. And then another 100 million years form or go by, and your lignite becomes more highly compressed. It changes its carbon a little bit, and now you have a bituminous coal. And then your bituminous coal, again, over 100 million years, is going to change into the oldest type of coal called anthracite. And anthracite is the best type of coal that we can burn because it has the most carbon content and it has the it's most powerful type of fuel because it's going to burn hot and it's going to burn a lot and it's going to be able to produce a lot of energy. So anthracite being the oldest type of coal, it's also the rarest. It's also the most difficult to get to because it's usually the deepest buried. So we only have a little bit of anthracite out there, but that's the one that we like to find and use. If you look here at this graph, it will show you the increasing heat and carbon content. Sorry, I had to let Butterbean out. Okay, so you have peat, which it says it's not a coal. It's just that partially decayed plant matter. But that peat then over time becomes buried, like I said, and turns to lignite. Then you go to your bituminous coal and then your anthracite coal, which is your hardest coal. It has the highest heat content, and your supplies are limited, of course. You should probably know these and then which ones are more desirable. This is just a graphic showing the coal reserves in the United States. We have a lot of coal, but it's usually the lignite type coal. Obviously, the anthracite coal is only found in a few areas in Pennsylvania, but we do have a lot of coal. You can break down bituminous coal into some subcategories, but I'm not really worried about that. So, some health effects of burning coal. Obviously, when you burn coal, you release a lot of emissions, and those emissions can be toxic and are considered pollutants. You also can release mercury, lead, sulfur dioxide, nitrogen oxides, particulates, and other types of heavy metals that we'll get into. Public health effects can range from asthma and breathing difficulties to more severe brain damage, heart problems, cancer, neurological disorders, and premature death. There's something called black lung disease that miners can get over time when they are working in these mines. They are breathing in a lot of coal dust. And when a miner spends most of his life in a coal mine, that coal dust is going to take that healthy tissue and basically give you massive fibrosis and turn your lungs black, and they get very small and they can die from this. So this is a picture of a healthy tissue of a 90-year-old school teacher there in the middle, and then a 40-year-old miner who's worked his days in the mines, breathing in all that coal dust. And you can see the difference there in the lung quality. Some more health effects of mining coal that don't really have anything to do with pollution, but actual working conditions. Lots of people die. Thousands of people die from mining coal in accidents. It is decreasing in this country. In 2019, only 24 people died in the U.S., and which is one of the lowest ever recorded. And then worldwide, we have about 12,000 people die each year from mining accidents. Obviously, because there's lots of coal being mined in developed countries, especially China, and they don't have the mining safety restrictions and all that stuff that we have here in the United States. So they are really putting their lives at risk when they go into these unsecure, unsafe mining areas. But that does not account for premature deaths due to coal burning, just emissions, which is approximately 800,000 people. So those coal burning emissions really do affect not just the environment, but human health as well. So coal can release specifically greenhouse gases, nitrogen oxides and carbon dioxides, and it releases a lot of sulfur dioxide, which forms your acid rain, and specific heavy metals and radioactive material. Mercury, arsenic, lead, uranium, radon, all of these things are in the ground, and they are in the lithosphere. They are naturally occurring elements. And when you dig out coal from a mine, you're going to have all of these materials within that coal as well. It's not pure carbon. If it was pure carbon, it would be diamond, right? Okay, so all of these excess radioactive and heavy metals are being burned and either going out into the emissions or being put in that slurry of coal ash, which we're going to talk about. Which affects on land here. We have the coal ash, which I'm going to talk about in more detail, and then hard panning at strip mines. We might do a lecture on some mining and different types of terminology having to do with the different types of mines. I would expect that to be on the exam. And when you extract all of the topsoil and all of the really nice surface soil of the planet, you get that hard rock, you get lots of clay, and all of that just is going to create runoff when it rains and disrupt your water cycle. So you can have desertification happening because of these huge strip mines as you make everything just drier. Luckily, we've stopped mountaintop removal here in North Carolina. When I started working in North Carolina, we still had mountaintop removal, and it's as disgusting as it sounds. It's literally when you blow off the top of a mountain to get to the coal, and that is really bad for obviously habitat, but also for erosion. And you get a lot of erosion and pollution into your waterways with that as well. So mountaintop removal is really bad, but we don't do that anymore here. But we do store coal ash. And I want to talk a minute about this. I would expect to see something about coal ash possibly on an FRQ, especially since there's been so many incidents of coal ash spills recently, especially in North Carolina with the Dan River coal ash spill that got such nationwide press. And it's something very easily that they can incorporate into this year's FRQ. So what is coal ash? It's literally a byproduct of burning coal. It's the substance that's remaining after you burn the coal. Just like when you have any type of burnt material, there's some sort of residue left behind. So this coal ash has a lot of toxic chemicals that are in it. It's just not the coal that's left behind, but it's also all of those chemicals, like sulfur, your sulfur, your mercury, arsenic, lead, all of these things that are can be remaining in that ash. So there's lots of things that happen in a coal burning